Welcome to all. This is in this course the last part of the friction, that is ladder friction. First, roughly I will explain the ladder. This everybody knows. See, ladder means in general what? See, there will be a wall. It can be either here or here or here or here, depending on the view. Or for example, see, actually this is all not required. This is the floor. This is the wall. One side, or this way I have shown. Now, anyway, if it is this way, see here, this is the vertical wall, this is isometric view, this is a horizontal floor, or we can call ground here. Vertical wall or horizontal floor or ground. Now, how ladder will be there? See, ladder will be like this. You have to ascend the ladder. Why? Need not tell much. Everybody knows what is ladder. So, this is the ladder. See? This is your ladder. Here, this is the ladder. See, there will be two members running here. They are interconnected. Here also, see, interconnected. Anybody who want to go, slowly will go like this. This way he will go. Reach the top. See, now this can be either top level or it can be else also. See, suppose you want to paint a huge vertical wall. Suppose ladder may go only up to here. See, up to here you require. Who knows? Wall may further continue. That is not our important. Okay, now see. I will take now this is a contact point, this is a contact point. I will project those 2 points here. This is isometric view. But when you see in the elevation, you can see only one point. See, this point. This point actually is midpoint of this one. Means see, there is some reaction here, some here or here, some reaction will come, resultant reaction will put here, and friction will come here, that will put later, here also, see, this contact point, this is the center of that one. Or, when you solve a ladder friction problem, nobody is going to tell you what is the width here, etc. They will tell details of the length of the ladder, weight of the ladder. Means you consider ladder as a line diagram. See, this is line diagram of the ladder. See, just a line diagram of the ladder. Now let W be weight of the ladder. See, where acting, I will tell later. W stands for weight of the ladder. Theta is, as per my sketch, is angle of inclination. Be careful. Inclination of ladder with horizontal. Very important, with horizontal. Why? Because you always want the angle with horizontal. Now here, other way. See, here ladder is like this. Here ladder is like this. So, see, these 2 contact point project here, this contact point. These 2 contact point here, see, this one. Here also same thing. See, what statement I wrote here is valid here also. W is the weight of the ladder. Theta is the angle of inclination of the ladder with horizontal. But remember, sometime examination unknown theta can be given with vertical. No problem. If they give theta unknown here, you make 90 minus theta here. Okay. Now, this is the basic part or simple explanation. Now, one very important concept. See, as usual, see, I will remove this one now. This is not required. Now onwards, we will consider only line diagram. See, now, this full I am removing. I am slightly shortening the camera also, the screen also. This is require more space. See, this full remove. I will remove once again later. Not writing anything now. See, now. This I have decided to continue, or in future same pattern will be there. See, make a note, but later I will tell you, once I start strength of materials, I will tell everything once again. This all I will tell. any concept, any principle which is required subsequently will be explained systematic way. Very systematic way, fully convincing way. Those who are serious will get fully convinced. They will tell 100% clear. So now regarding ladder friction, see right here, regarding ladder friction, regarding at present we are in the ladder friction. Ladder friction, you write here, what all principles and also what? Some basic concept, everything required will be told now, will be told now, will be told now. Later, see now do one thing, you take black color advice, red color warning. Warning. Remember, black color advice is for those who are sincere and they go through everything, study thoroughly, or they believe in me, or they really want to study from me. There are a lot of things you can study. If you go through the entire course, I will see that you are so perfect, your level of structural knowledge will be so high. Later see, I will start uploading everything now. Blunders committed, do's and do nots, not for mechanics, entire structure engineering, one by one I will upload. So many angry people will be there. What they told, they suddenly will realize, oh, what all I told so far is wrong, and this person is 100% correct. We have to believe him. Therefore, they will feel little ashamed. Some of the concepts they shouted and shouting voice they told in the class, this is like this. Now I will prove it is not like that. It is actually like this. Rectify. They have to believe. Unless they stick to their concept and knowing that they are wrong, they may pretend that they are not wrong. That we can't do anything. So those people who sincere and hardworking and follow everything, for them it is advice. Those who do not follow properly, not go through all the classes, do not make all necessary notes, do not read, go through the class again and again till concepts clear, everything done. And once in a while, you should, where concepts are there, once in a while, once again you have to go through. See, YouTube class, it is permanent. See, when I take class in Zoom, some courses I am running, there after some time I delete that classes. Why? Space problem is there. I do not want it to be permanent. Next batch I will take once again. Therefore, there I will tell them, be careful. I will give enough time there, maybe more than 6 months, 8 months like that. But here, YouTube, for my channel, no strike can come because copyright strike, I don't copy anybody, see. Come with a pen, side by side a calculator, it's not here, I have searched it now, and with my brain. That's all I bring to the class. No script, no handwritten script, no reference, no writing, nothing like that. Therefore, my channel cannot get any strike, no copyright act will apply on me, nothing possible. Therefore, YouTube will not have any action on my channel, I am sure. They will be knowing it. Oh, this is pure education channel. The person is not using any other source. Therefore, this will be a permanent. Therefore, in case you don't study and see, any day you can study and not serious, for them it is a warning. As I go further in the ladder friction now, when I solve examples, if not clear, advice is go back, come to this class, study and go back, or not required. Those who are serious would have already studied it. Warning for those who are not serious or not dedicated. I don't care about you. See, same thing. I don't care. Yes, I should be harsh. This I told hundreds of times. Okay, now I will tell that one. Okay, I will clean the board. and tell all the principles now. Camera, little have to shorten now. Okay, now all principles and concepts required for ladder friction already told. What I am telling now onwards in this class will be, I already told you, advice come warning. I won't repeat once again. Go through earlier, what I told just now earlier. See, right now, theta is angle of inclination of ladder with horizontal. See here, with horizontal. It can be this way or this way. Both I will explain. Right now, theta is angle of inclination of ladder with horizontal. But one thing, do not by heart any expression with respect to theta, because examination sometime they tell this is theta. The ladder makes an angle theta with vertical, they will tell. In that, therefore, right here, see, you write here, right now for explaining theta is angle of inclination of ladder with horizontal, or write a note here. Sometime in some questions they give theta with vertical. So it is better. For writing you require theta. You remember, instead of theta, in the mind you remember angle of inclination of ladder with horizontal. That angle we are using. Something I am going to tell now. I will write theta. So if I write something as theta here, that theta is angle of inclination of the ladder with horizontal. Okay. Now, this is called bottom of ladder. This is called top of ladder. Some people, instead of bottom of ladder, they call foot of ladder. Same here. See, bottom of ladder or foot of ladder. This is top of ladder. Not required. Top of ladder. Okay. Then let L be length of ladder. Length of ladder. Length of ladder means, make a note here. See, that is measured along the inclination, not this way. Length of ladder. L be length of, some symbol, L. Then, right here, x naught, y naught. See, the ladder is inclined. If I project vertically down on the horizontal plane, see, on the horizontal line here, this is x naught, this is y naught. Or here, see, this is x naught, this is y naught. So, right here, x naught is the horizontal projected, see, you should write here, projected horizontal distance of the ladder, projected vertical distance of the ladder. Then write once again, or you can tell x naught is horizontal distance of foot of ladder from the wall. Y naught is what? Vertical distance of the top of the ladder from the floor. Or when the ladder is inclined, horizontal distance is x naught, vertical distance y naught. Okay, first write this one. Now, in examination, they can give any data. Theta can be given, length can be given, x naught or y naught can be given. It is their choice. So, after writing all this, you write one note here. See? Note here. Relationship. See, we have cos theta, both the sketches, see, both the sketches common. We have cos theta, you can use it easily. Cos theta equal to, here, see, cos theta equal to x naught by L. X naught by L. Even same there also, see, what I am writing is valid here and also valid there. This is y naught, okay, y naught, x naught by L. Therefore, x naught equal to L into cos theta. And sin theta equal to y naught by L. For both, y naught by L. Therefore, y naught equal to L into sin theta. Make a note. Therefore, you write some statement now. If the length of the ladder is given, see, if the length of the ladder is given, see, horizontal floor can be, if it is an inclined floor, helpless. That all will correct later. One question I will do later when the floor is slightly inclined also. Not now, special question. There, some corrections are there, okay, right? But 99.9% questions are like this. See, now make a note here. Therefore, what all I tell you right here. If length of ladder given, you should write here what I am telling. If length of ladder given and angle made by the ladder with horizontal given. Suppose the angle given is with vertical, you get with horizontal. Then consider the angle with horizontal. Then horizontal distance, that is projected length from the foot of the ladder to wall, this horizontal distance will be whatever is length of ladder into cos of the angle. Vertical height will be whatever length of the ladder into what? See, that is whatever length of the ladder into cos of the angle, horizontal, whatever length of the ladder into sine of the angle is vertical. Or you can do one thing. This is simple, see. It is like an inclined force. You know it. If it's an inclined force, go back, see. If you represent by hypotenuse, imagine this a triangle is what? Three forces. One horizontal, one vertical, one inclined. Horizontal and vertical are the components. Then you know it. See, this is an inclined force if you take horizontal component equal to length into cos theta, vertical is length into sine theta, that theta should be with the horizontal, or horizontal component equal to that inclined length into cos of the angle with the horizontal, vertical height equal to inclined length into sine of the angle with vertical. Make a note. First, this is simple to understand. Now, further is there. Okay, one remove now. See, later. See, you do not have to waste time. Every class when you do the question, if the length is given here, you don't have to write, we know that cos theta. You write directly what here? This length into cos theta. Those who find difficulty, you write trigonometry there. I will tell them. Suppose the length is given 6 meter. Angle is 40 degrees. I will write here directly 6 cos 40. Suppose somebody got difficulty, write here cos 40 equal to this horizontal length x naught by 6. Therefore, x naught equal to 6 into cos theta. You write that way. Those who find difficulty. But I will not, next class onwards, I will not explain again and again. I decided, see, when I start strength of materials, see how serious warning I will give you. Okay. So some will tell this person is only giving warning. Okay, receive the warning. It is for your benefit, not for my benefit. Okay. Now, this is over. Now, there one more note you make here. See, one more note. Sometimes, who knows? Sometimes, in the question, length may be given, x naught can be given, and y naught can be given. The question, this all you have to make a note. In the question, they will tell a ladder so much meter long, and the bottom of the ladder is at so much meter from the wall, and top of the ladder is so much above from the ground. They will give you L x naught y naught. If they give L x naught, L x naught y naught, all three will not be given. They can give they can give what? X naught and y naught. See, 1 minute. They can give x naught and y naught. If they give x naught and y naught, you can find L by what? Root of x naught square plus y naught square. Right here. This is one thing. Or, then, one more thing. Then, you can find theta by not sine theta. See, you can find theta by tan theta. Tan theta equal to y naught by x naught. Y naught by x naught. Not cos sine. Okay, then, sometimes they will give you length and x naught. Length will be given, x naught will be given. Then you find y naught by what? Root of L square. This is valid for both the sketches. L square minus x naught square. Find the what? Y naught, find Y naught by this equation. Okay. Or right here, they can give length and Y naught. 1 minute. Then if they give length and X naught, then your cos theta will be, see your theta, you connect X naught with L, then cos theta equal to X naught by L. Therefore, you can get the value of theta with horizontal. Make a note. Someone will tell, sir, these are all easy, sir. Yes, correct. That's why I told advice come warning. Okay, then, right here. Sometimes they can give L and Y naught. I told first what? First they give L and theta. Then I told L and X naught. Sometimes they'll give L and Y naught. If they give L and Y naught, then you have to get the value of X naught. How? X naught equal to root of L square minus Y naught square. Then if Y naught given and L given, to find theta, you write sin theta, not see, you connect Y naught with L, you write sin theta equal to Y naught by L and get the value of theta. So in the question, X naught, L given, see, so many possibilities. Length given, theta given, get X naught, Y naught. Then X naught given, Y naught given, get L and theta. L given, X naught given, get Y naught and theta. L given, Y naught given, get X naught and theta. For both the sketches, this is termed only. This also I will not tell once again. Okay, then next. Now regarding, first consider weight of the ladder. See, I will remove the sketch now. Weight of the ladder and where it acts. See, first I put a sketch here. Weight of the ladder. See, let W be weight of ladder. Weight of ladder. Now, important is where it is acting. Where it is acting. Acting. See, it will act, now depends, remember. Now, there are two cases are there. Two cases. Uniform ladder or non-uniform ladder. Non-uniform ladder. See, uniform ladder. Maybe. Or non-uniform ladder. Maybe something like this. Yes, possible. See, it is their choice. Or some other change so that it is not uniform. In the question they will tell it. Therefore, you make a note here. If it is uniform ladder, the weight W will act, 1 minute, before that you write here, irrespective of uniform ladder or non-uniform ladder, make a note here, irrespective of uniform ladder or non-uniform ladder, weight W will always be act through not centroid, center of gravity of ladder. Not centroid. Why? Now weight comes. Centroid is for moment of inertia chapter, area. Now weight comes. Center of gravity of the ladder. Okay. Now write further. If it is uniform ladder, I am dictating, if it is uniform ladder, center of gravity will be exactly at midpoint of the length. Midpoint of length. See, that is midpoint of length. See, that is, see, center of gravity G. Show a sketch here. See, here. G. Center of gravity G here. Center of gravity G here. Then weight will, right, then weight will act through G. You make a note here. See, it will act here. Write one more sketch. Write one more sketch. Don't waste time. Write one more sketch. Little out of scale here. See, little this side. Okay. That's why it is becoming, this is theta. Okay. Weight will act here. W. This is, now see. Now, see, theta. You make one more note, not over. This sketch you are write once again. See, then this will be L by 2. This also is L by 2. You make a note here also, right? This is L by 2. Once again sketch you require. You cannot tell I am using the same sketch because I am teaching L by 2, L by 2. Now do one thing. You don't waste time. If I project this here, these two will be exactly, see, if this point is midpoint of this line, the projected point is midpoint of this distance. This will be x0 by 2, x0 by 2. If I project here, you don't require actually, because when you take moment, this is required. This is not required. Still, if you want, it is what? y0 by 2, y0 by 2. Actually not required, y0 by 2. Right here, same way here. You write L by 2, L by 2 along the ladder, or this way it is x0 by 2, x0 by 2. This will be, if you want it, y0 by 2, this also y0 by 2, make a note. Or there is a mathematical rule is there. See, I will tell you mathematical rule before going further. See, one mathematical rule. See, very powerful rule. I will not tell again and again this one. There is a mathematical rule. This everybody should know it. Mathematical rule. See, suppose this is valid for any sketch. If this is an inclined plane, inclined portion, if this is L, if I project here and project here, if this is x0, if this is y0, then this point, any point P, see, P is any point, any point. If the point P is center here, see, right here, you write P is any point, any point. Now write here, if P is center of L, this is L by 2, this is L by 2, then if I project here horizontally, this also will be x0 by 2, x0 by 2. If I project vertically here, these two will be y0 by 2 and y0 by 2. Make a note. This is when the center. Okay. Now make a note. One more note right here, very important. See, one more note. If there is an inclined line is here, and see, project here, inclined line here. You take any point here, P. It is any point P. P is any point. Any point. If this length is L, and if this distance is what? If this is L, if this is L dash, you write here. It is any point. It is not midpoint. It can be anywhere. If this is L is the length, any point P, L dash. Right here, L is the inclined length, and L dash is the distance of the point from any one end. Okay, take from bottom. If you take from bottom L dash, then what you do is you get L dash by L. L dash by L. That is ratio of L dash by L. That is ratio with respect to bottom. Very important, with respect to bottom. See, with respect to bottom, that is L dash from bottom. Say equal to say K. Then you need not bother from the bottom. See, if L dash is from the bottom, from here to here is, if this is, see, now see, therefore, what will happen now? Therefore, now this L dash will come K into L. See, L dash by L equal to K means L dash equal to K into L. Ratio of L. If this is K into L, this also is K into X naught. See, it's a mathematical rule. And same way, if I project here, from the bottom only or see, from here only, not from top, this distance will be K into Y naught. Or I will give an example for you. See, suppose there is an inclined line here. Imagine this length is 10 meter. 10 means easy for me to calculate. 10 meter. Okay, then imagine this length is 6 meter. And this length is 8 meter. This is 8 meter. This is 6 meter. See, I should be careful. Why? When I give dimensions, I should be careful. 6 is 8 square plus 6 square is 10 square. Correct. I know that much mathematics. Now, example. If this is the midpoint, see, if it is a midpoint, then this is 5 meter, this also 5 meter. You write one more, no, see what you do is you first write the sketch. You first write the sketch and mark the midpoint. Imagine this is the a point P. You mark a point P, say midpoint. Midpoint of the inclined line. Now, don't write here. Write one more sketch and then tell. Then without calculating, see, this is 10 means this is 10 by 2 meter. This is 10 by 2 meter. If I project here, this will be 8 by 2 meter. This also is 8 by 2 meter. And if I project here, this will be 6 by 2 meter. Second time sketch you write 6 by 2 meter. Make this note first of all. Then do one thing. Write one more. See, this is for midpoint. Now write one more note here. See, remember, I am using the same sketch. It is my choice. You should write the sketch once again. Be careful. Don't be lazy and skip. K into what? K into Y naught. Okay. Height Y naught I written here. Y naught. Okay. I rubbed it. Y naught. Now, one more example. Imagine this is an inclined line. Once again, I will take 10 meter. See, easy for me to understand. This is 10 meter. Imagine. Let this be 8 meter. And let it be 6 meter. Okay. Because it should be 6. 1 minute. When it's 10 and 8, it should be 6. Why? 10 square minus 8 square root is 6 meter only. Okay, camera, no problem. Then you make a note here. Mark a point P anywhere you want. You do one thing. Mark 2 points. One point you mark here, P1 here. One more point you mark P2 here. P1 from here, this is 10 meter. You take 3 meter. P2 free, 10 meter, I'll put here. This is 10 meter. P2 from here, you take from here only 8 meter. Not 8 meter, already 8 meter is there. Okay, 7.6 meter. Randomly take, not 3 meter, okay. You take some, not 3 meter, 3.5 meter. Take this way. Now, you write this sketch. First you write the sketch. Write, let one point P1 be at along the inclination from the bottom 3.5 and one more point P2 from the bottom 7.6. You write this much and then write, consider P1. Consider P1. Okay, now 1 minute. I'll forget this number, 7.6. Okay, forget. When you consider P1, do not consider P2. You write one more sketch showing only P1. Okay, this P1 over. Now, I want what is this distance and also what is this distance. This distance will be, see, this is 3.5 in 10. So the ratio is 3.5, distance from foot, 3.5 by 10 multiplied by 8. See, or why that much? See here, 3. 3.5 by this distance equal to 10 by similar triangles actually. So this distance is, if you want this horizontal distance, it is this, how, right here, how much is this distance, how much part of 10 is this one, 3.5, divided by full length 10. So same ratio, that 3.5 by 10, same ratio with respect to 8. So into 8 meter. Here, if you want this distance, see, this is 3.5 divided by 10. See from here, 3.5 divided by 10 is the ratio of this point from here, multiplied by, with respect to 6, it is 6 meter. You write, the answer is not required. Write that way. Then write, then if you want this distance, it is 8 minus, you write here, suppose this answer is there, how much it is? Okay, I'll calculate the answer. Why? I don't have calculator here. I shall print the calculator. 1 minute. Calculator is not there. I'll pause. Okay. Write the answer here. 3.5 by 10 is 0.35. 0.35 into 8. This is 2.8 meter. This will come, answer equal to 2.8 meter. This will come 3.5 by 6 into 6. 3.5 meter. Oh, not 3.5. Oh, that 3.5 is not this 3.5. I write here, it is not this 3.5. I will put 3.50 meter. 50 meter. By chance it came same. Don't think that way. Then, if you want this distance, right, it is 8 minus 2.8 meter. If you want this distance, write what? 6 minus 3.50. This is for the point P1. Okay, now consider P2. Right here, once again. Consider P2. Draw one more sketch. This time, see, this is how much? Base is 8 meter. Okay. 8 meter. P2 is somewhere here, upper side. How much? I have given P2 much. See, P1 I have given near to this point. P2 far away, no problem. See, this distance is how much? 7.6 meter, just now I told. Then, see, once again, project here. This distance is, see, this is 7.6 meter with respect to 10. Okay. 7.6 with respect to 10. With respect to 8, how much? Write the answer. 7.6 divided by 10 into 8. 6.08 meter. Then if you want this distance, it is 8 minus 6.08. Now here, if I want this distance, by chance if you want this distance, you don't require. It is, see, this is 7.6 with respect to 10. So 7.6 with respect to fraction, factor, into height is 6. 7.6 with respect to 10 into 6 is 4.56 meter. 56 meter. Then this distance, if you want, it is 6 minus 4.56 meter. Make the example. See, I am teaching as if students are, people are, what? High school, knowing high school level mathematics. For an engineering class, this should not be told. Someone will tell me, what is this you are telling? They know all these things. I will tell you do not know. I will tell them, you do not know. Okay, I have seen difficulty. Okay, now, right, one more thing. Now, by chance, the distance P, right, one more sketch here, is given with respect to top. See, L dash from there, L dash. Right here, that is right here. Suppose L dash the ratio of with respect to not bottom, with respect to top. That is K. This is L dash, this is K, L. That is, they are telling you what? Where is the point P, any point, with respect to top, L dash. Then, see, same thing here. This distance will be what? And here, see, If it is from the top here, then this will be from here, this will be from here, this side. Why? Project the top, then this will be what? This will be k into y naught. This will be k into x naught. This you can calculate later. Or take an example. See, I am not leaving anything for confusion. Everything should be clear. Once I explain all these, if somebody gets doubt, sir, how you got that 3.5? I will tell, leave the class. Don't come to my class. I will tell, don't come to my class. Okay. See, or take an example. Imagine here, this way, see, 10, 8 and 6, same. No change, because easy for me. 8 meter. This is 6 meter. This is 10 meter. Suppose you consider a point P1 right here, a point P1, which in the question they told a person is standing at what distance from top of the ladder, or I'll tell you later, P1. Imagine this is L dash. This is L dash. If that is L dash, sorry, not L dash, I told you, numerical value. This is 7.2 meter. So therefore, see, project the point here, right here. You first put this sketch, then write. Therefore, write the sketch once again. There you write, see, from the top they told here. So if I project here from top and here also, see, from here. When they give ratio or, see, now from here. Last time from here given me, see, this distance and this distance. Now from here given me, see, project here. This distance is 7.2 by 10. See, 7.2 length along 10, then into 6. Get the answer. And this distance is 7.2. See, from here, 7.2 with respect to 10. 10 multiplied by 8. Get the answer. (7.2) divided by 10 into 6 is 4.32 meter. This is then right here, this distance is 6 minus 4.32. Here, this will be 7.2 divided by 10 into 8. 5.76 meter. Therefore, then this distance is 8 minus 5.76 meter. Okay. Be careful. Now, one more thing I will tell you. Suppose, now see, example, consider a ladder. Okay, see, ladder here. You write the same. To save the time, I will do one thing. This is the ABC. This is the ladder. Ladder I won't write now. Ladder. See, length of ladder, imagine 10 meter. Easy for me. 10 meter. Imagine this is 8 meter. This is 6 meter. See, 8 and 6, we don't know. It is not given. It would have been calculated value. Don't bother. Now, suppose in the question, right here, suppose in question given weight of ladder is, some say, 600 Newton. 600 Newton. Then understood that it is case of uniform ladder. Therefore, weight of ladder will act through center of gravity of ladder that is at what? Center of ladder right here as shown. Come here. Correctly through center, mark the weight. Right. As shown means put the sketch. See, correctly through center, mark the weight of 600 Newton. Then directly, in case you write here this distance and this both are equal, 8 means 8 by 2 meter. This is also 8 by 2 meter. And here, if I project here, if you require, you don't require it. For taking moment, this is required. Okay. 6 by 2 meter. 6 by 2 meter. You write this sketch, then write. Now, next statement. Same thing. See. Suppose given weight of ladder, or in the question they will tell a ladder weighing is some random 8 kilonewton, see 80 Newton per meter. So many examinations they told a ladder weighing 80 Newton per meter. Okay, some number. Okay, then again understood. Right? That you write. It is a case of uniform ladder. Therefore, that weight W will act through center of gravity of the ladder, which is exactly center of the ladder. But in the question, they told weight of ladder is 80 Newton per meter. That is 1 meter length. Now do one thing, but you have to calculate the total weight of ladder is equal to 80 Newton per meter multiplied by length of the ladder, 10 meter. 10 is length of the ladder. Equal to 800 Newton. Now Newton, then right here, 800 Newton. See, here no Newton per, see, 8 by 2, 6 by 2, 6 by 2. This also cleared. Okay, now make one more note, last note. Then something else I will tell. One more note. See. Suppose in a question, it is given that weight of ladder is, say something, okay, 600 Newton and center of gravity of ladder is at total 10 meter. Same thing I am telling you, ladder of length 10 meter, same dimensions, is at 4.6 meter from foot of the ladder. Center of 4.6 meter along the ladder, important, along the ladder, understood, ladder from foot of ladder. That means your ladder is something like this. See, here total length is 10 meter, non-uniform ladder. Here more weight, there lesser weight. Centroid will be this side. Right. Then, see, if the question, see how much distance here? This is 4.6 meter given in the question. See, given in question. Then, when you write the sketch here, see, right here, same 6 meter for understanding. I am not changing. 6 meter. This is 8 meter. The weight of ladder is not center, little this side. See, this is the weight of the ladder. How much? 600 Newton. In the question they told this distance is how much? 4.6 meter. Right here. You put this sketch. Then write one more sketch, because when you take moment here, load into this distance required. So you first write this sketch. Okay. Once you write this sketch, then write one more sketch and tell, then this distance is 4.6 by 10 into 8 equal to meter. Answer not required. And this is not required. Okay. If you want that much eager, write distance. This is what? After subtracting, this is 4.6 by 10 into 6. Write this way. So when you take moment about A, we will write 600 into this distance. Okay. Now, one more. Suppose in the question, same thing given, but weight of ladder is at 6.4 meter from what? 6.4 meter from, not 6.4 meter, I'll put it somewhere else here. Is at total 5 meter. See, once again tell 4.6 meter from top of the ladder. From top of ladder. Same 4.6 ladder. Understood, along the ladder. That means your ladder is something like this. See here. It is a non-uniform ladder. See, this length is 10 meter. They told center of gravity is at what distance? Center of gravity is at 4.6 meters from that side, they told. Then right here, one more sketch you write here. Write one more sketch. There you do one thing. See, the total load is acting here. How much? 600 Newton. They told, see, okay, a minute, I put here 600 Newton. They told this distance is 4.6 meter. Right here. You write one more sketch. See, write one more sketch. Okay. First put this sketch. Now do one thing. Right. Then you write here. Then write one more sketch. See, this is 4.6 meter. Then you get this distance, and see, when you refer there, see, you get what? Project here. See, it is the right side. So from right you are getting it. And here also from top you will get it. See, this will come. Be very careful. Then this distance is 4.6 by 10 into 8 equal to meter. That will come. I require it because I will tell you why. 4.6 divided by 8 into 10. 4.6 divided by 10 into 8. It is 3.68 meter. But remember, when you take moment here, you require this distance. Then, right here, then this distance will be how much? 8 minus 3.68 equal to 8 minus 3.68 equal to how much it is? 4.32 meter. This is how much? This is 4.6 by not required by 10 into 6. Okay, write the answer. Or you can make one more note. Or you make one more note. Or instead of struggling this way, see, struggling that way, if they give 4.6 there, you get this distance. What is there? If there is 10 from here, it is 5.4 meter, calculated value. Then this distance is what? 5.4 by 10 into 8. Same answer will come. 5.4 divided by 10 into 8. 4.32 meter. That also will do. Your choice. So these all I will not explain when I solve the question. Okay. Now, next point I want to explain. So many concepts are there. Remember, this ladder friction, lot of concepts are there, but very interesting. Okay. Now, next. Suppose for some reason, along the length of the ladder, see, this is L. along the length of the ladder L, this is, see this way, length of ladder L, there is a point here P at x from here. At x from here. Why x is, some reason is there. Sometime in a question paper they will ask you how far a person can walk along the ladder before ladder slips. We will write, let the person be at x from foot of the ladder. Okay. If you take x here, then this distance will be, see, first you write this sketch. First you write this sketch. Then write, then this distance will be, see, if this is x naught, this is y naught, you can do one thing. Suppose this angle is theta. This distance is, you write here, x by L, see, x by L into x naught. X by L. This is x from bottom with respect to L. Same ratio from bottom, that ratio maintained here, x by L into x naught. This one. And this distance actually not required is x by L. This x is not this x. See, this x is a variable x into y naught. Okay. Or you can do one thing. If you know trigonometry, see, when this is x, this is theta, you can also write this as x into cos theta. Both are same. You can write this as x into sin theta. See here, x, see here, x by L into what? X naught, or x naught by L. See here, x naught by L is, or how you get it? Cos theta. Or imagine this is an inclined force. Its horizontal component is inclined force represented by length x. X into what? Cos theta, x into sin theta. This also will do. When I solve a question, whichever I feel comfortable I will do, nobody can question. Okay. This is with respect to positioning. Suppose you know the position of any point along the ladder, if you want a projected length in horizontal, what you do? That part length by full length along the ladder multiply by full horizontal length, or that part length whatever is there into cos theta is horizontal, into sin theta is vertical. Theta means need not be theta, they can give this theta. Theta means angle, this angle here. If they give theta there, it is 90 minus theta then here. Our reference of cos sin is with respect to what? Angle made by the ladder with the horizontal inclination. This also I told. Okay, now I will think what further required. 1 minute now. I will pause the recording for some time and write what is. Now the most important part, reactions on ladder. See, you should write what I tell. When we solve any ladder friction problem, we always write free body diagram of the ladder. When you write free body diagram, what all I am dictating you write. When you write free body diagram of the ladder, you consider weight of the ladder depending on what? Where they given centroid, center of gravity, if not given center, then any other weight acting on the ladder. Suppose a person is going up or down, coming depending on that one, position they will give, or you have to think about it. Extra weight on the ladder. Then ladder is resting on the wall at the top and placed on the ground at the bottom. I will call ground now. Instead of wasting time, horizontal surface, base or ground I will tell. See, ladder can be like this or ladder can be like this. Theta will not required now. See, now A right here, in both the cases, A is the all you have to write if you are serious. A is the contact point of the ladder at the base. C is the contact point of the ladder at the top. A with the horizontal base, C with wall. Now, irrespective, see, there are two types of surfaces. Sometimes they can give in a question, surface is smooth or rough. See, you write all this one. Surface is smooth or rough. Smooth or rough. If nothing given, understood, it is rough. Smooth surface means no friction. Practically, it is not possible. But sometimes, see, suppose you put a ladder on a mosaic floor, very dangerous, or granite floor, then very risky one. You require some extra arrangement to prevent the slipping. Someone has to hold it. That all will come later. Wall can be what? Again, rough or smooth. Usually, wall is always rough only. Ground also is rough. But anyway, it can be smooth or rough. Make a note here. Irrespective of all I am telling you to write, irrespective of it is smooth or rough, there will be normal reaction on the ladder from the surface. See here, right here. Let RA, see, this ladder in both the cases, see, in both the cases, whatever is the weight, see, this ladder will press the ground down. Here also, it will press the ground down. So from ground or base, there will be upward reaction. Since I called A, RA and RA. So RA is the reacting force, normal reacting force on the ladder from the base, at the base. Whereas the ladder will push the wall this way. See, when you apply load here, ladder will push the wall outwards. So from the surface here, inward reaction will come. See, here also, we'll push it this way. Don't by heart left and right side. See, this way. So RC is, I am not writing here, you should write, is the normal reaction on the ladder from the wall. Okay. Irrespective of whether ladder is or smooth or rough. Now come to friction. In the question, if they tell surface is smooth, that is, friction is actually practically it is not possible. Or by chance, you pour oil on the floor, put the ladder, it will slip, see, very, very smooth. Or for the wall also, you put oil, very dangerous. Anyway, theoretically possible, but practically not possible. But when you solve a question, what they told you should consider. Or if the surface is very, 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 very smooth, then maybe they will think, ignore friction. Actually, safer side. Friction is actually helping you. When something is helping you, if you ignore it, it is always safer side. For this all, I am making separate class. When somebody may be helping you, then if you imagine he is not helping, you are on the safer side. When you are not knowing whether somebody is helping you or not, if you assume that he will help you, it is danger side. This all practical structure engineering require. Separate class I am making for that one. So much of practical knowledge required. So right here, if the I am not writing everything now, dictating. If the surface is smooth, see, if the surface is smooth given in the question, then there is no friction. FF is not there or zero. FF means frictional force. See, FF is frictional reaction force on the ladder. Everything is on the ladder. Very important. So R is in general, R is the normal reaction on the ladder. It is always there. Irrespective of smooth or rough, normal reaction is always there. But FF is the frictional force. See, I am putting green color here. There's a reason. See, green color. Frictional reaction force on reacting or frictional reacting force on ladder. Either frictional, okay. Reacting force is better. frictional reacting force, okay, black color, okay, on ladder from right here, from that surface on which it is resting. Therefore, at the base, now do one thing. First you consider general case when both ground, you write here, both ground and wall are rough. Okay, 1 minute now. One thing forgotten. Also note, this FF will become FF limit equal to mu into R when the ladder is on the verge of slipping. You know, limiting friction. If the ladder is on the verge of slipping, then only your FF will change over to, you see, this green color. This green color FF will change over to red color FF limit equal to mu into R, where mu is the coefficient of friction for the contact surface. Okay. Now, on the verge of slipping. Okay. Now, in general, that is, imagine both ground and wall are rough. So friction is there, friction is there, friction is there, friction is there. I will tell only once. See, this ladder, tendency when somebody is going here, it may not slip, but tendency is to slip. See, this ladder will slip this way. See, tendency is slip this way. Or this ladder will try to move this way. When it tries to move left side here, friction is right side. See here, this ladder will try to move to right side, friction is left side. So common to easy to understand. I should not explain this one. See here, if ladder is like this, see, this way ladder, slipping this way, friction this way. Here, this ladder is this way. See, friction is this way. Okay, over. And when this ladder, this slips left side here or slips outward, you remember, it slips outward. When this slips outward means here left side, there right side, then the top will come down. See here. When it slips this way, this seat top, it will try to slide down. So friction is up. Friction is up. So right here, FRA is the, I already explained, normal reaction at the base. Don't by heart ABCD. FFB, see, green color, frictional resisting force on the ladder at the base this way. Here, RC is the normal reaction at the top this way. FFC is this way. This already explained, right? Both of them. Now, very important. Some competitive examination, they cheat you. See, I will tell you here. Very important. Okay, if the ladder is stable, means no slipping. Ladder is stable and has not reached, it is stable and has not reached the stage of slipping. Not reached. Ladder is stable. There is no question of slipping, nothing mentioned. Slipping is not there. Then I will not tell once again. See, your FF is not equal to FF limit. See, FF frictional force will reach limiting value when the ladder is on the verge of slipping. If it is a stage of stable equilibrium and slipping stage is not reached, then frictional force is not equal to FF limit, or you can tell, this is very important. I will not explain. Then your FF, either here or there, your FF will be what? It will be less than FF limit. And FF is, see, therefore, and your frictional force and R are not connected by mu. Not connected by mu. Or you can tell here frictional force at that time, frictional force is independent of mu. Independent of mu. It does not matter on mu. It is independent of mu, or FF is a separate unknown. Remember, it is a separate unknown. You cannot write FF as what? FF limit. But remember, you write here. So if the ladder is in equilibrium and slipping, limiting case has not reached, that is, it is not on the verge of slipping, then that FF has nothing to do with RC. Right here, these are not connected. Right here, these are not connected. These are not connected. These are not connected. These two are not connected. They are independent. It is like a vertical reaction, horizontal reaction, like a horizontal reaction, vertical reaction, which are independent. Make a note. I will not tell once again. Right here. But. Now right here. But. Where I'll write now? Okay. Now I write here. Okay, now I'll write here. But. When the ladder is on the verge of slipping, very important, on the verge of slipping, that is limiting case, limiting static friction case, okay, limiting friction case, you write limiting static friction case, then your FF will change over to FF limit, that will be equal to mu into normal reaction. Okay, right. Then, right here. Then, see here. This green color FF, see right here. This green color FF. See what I wrote, green color here. Green color FF. Then this FF will reach what? It will become FF, red color. See, it will become this one. FF limit at C. This FF B will become FF limit at B. This will become, okay, remove this one now. Okay. This FFC will become FF limit at C. This will become FF limit at A. Here A, no? Oh, this is FFB. Okay, okay. Print mistake earlier. Okay, sorry, print mistake. Yes, it is not B, it is A. Okay, sorry. So this is called a print mistake. Don't bother. No, somebody will comment. You don't know A, B, C, D. Okay. A, not B, it is A. By mistake I wrote because I saw that point. Correct it. I told technical mistake will not be done in the class. A, B, C, D is not a problem. I am also a human being. Okay, change it. Okay, then, see, it is connected now, and now, see, it will become F mu R, or equal to mu into, mu is black color, see, it is a constant, equal to, I don't think, everywhere I write here, equal to mu into, equal to mu into, equal to mu into, equal to mu into here, mu at A, mu at C, here mu at A, here mu at C. It can be equal depending on the question. Mu, respective mu into what? Into, this is normal reaction RA equal to into mu at C into normal reaction RC equal to mu into mu C into normal reaction RC, mu A into normal reaction RA, correct? RA, mu A, RA, mu C, RC. Mu C, RC, mu A, RA. Camera, I'll check once. Okay, no problem. Everything is okay. Then it will become mu. Now remember, now, see right here, now what? FF is connected with R. Connected with R, therefore, if R is the unknown, in FF limit, that R comes, it is not unknown. So, or now that much you are knowing it now. Or if mu is known, see, if mu is known, then there is only one unknown here. Which one? RC, mu is known. You write here. If mu is known, then both reactions, even though there are two reactions are there, they are actually only one unknown. Okay, over. This all I explained for you. You write, make all this note. See, okay, now this you make a note. This is the case when both are what? Both I am considering a rough surface. Now some note you have to make. I'll dictate here. Directly note. Sometime in the question paper or in a question, they will tell smooth surface. See, if they tell wall is smooth, then FFC is not there. Where smooth surface given, do not consider friction. See, then, see here, that's all. That's all. You write a statement, this you know it. In case in the question, if they give surface as smooth, then that's contact point. Do not consider friction, leave it, only normal reaction. So, if they tell wall is smooth, then, see, only R. If they tell base is smooth, actually base smooth is dangerous one, then only R. Or simple language you write, if surface is given as smooth in the question, a smooth wall or a smooth ground or a smooth surface, then that contact point, do not consider friction. Okay. You should write each and everything what I tell. Do not consider friction. And lastly, warning, if the ladder is not, see, if the ladder is in stable equilibrium and it has not reached the verge of slipping, then frictional force, if it is there, smooth means not there, frictional force is separate unknown. It has nothing to do with R. To cheat you, they will give mu here. They will tell, take mu equal to 0.3. Some people will write suddenly, see, FFC equal to 0.3 into RC, gone case. I will tell it will become blunder. But FF limit will become mu into normal reaction R only for limiting case, that is when the ladder is on the verge of slipping. When ladder slips, see, base it will go outwards, friction inward, wall it will move down, friction up. This much is sufficient as a basic concept. Okay, now, second point. So I told you, wherever smooth surface given, do not consider that one. Okay. Now, some important points. Everything I am telling you now only, so that later there is no confusion. See, it's all over. Okay. Any by chance, if any ABCD problem is there, you correct it. Don't make an issue of that one. You write that person right here is actually technical mistake. I told I will not do it. This ABCD all silly matter. It happens sometimes. By the way, yesterday I given a question for one mathematical test for answering. Nobody answered so far. Okay. You can, in the comment section, you can write the answer. If you got the answer briefly, you can write, yes, I got the answer, mu equal to 0.2, and you should tell what you have done. You should write, I did this way, briefly, 3-4 lines in the comment section. Actually, it requires 1 minute. I am not telling. Okay, over, that's all. That's all. In case you do it, you write in the comment. Or do one thing. If you write in the comment, somebody will see the comment and they will try. Okay, no problem. But anyway, they will be knowing they did not get. Perfect solution I will give later based on a condition I told you. Okay, I will not tell condition again and again. Now, one important concept here, for a ladder, see, either that way or this way, see now, I should not tell, only one side, okay. Ladder. If the ladder is placed like this, or if the ladder is placed like this, see here, angle theta with, I will do theta here, I will take this as alpha. Here I will take this theta, this I will take alpha. Theta I will tell angle with horizontal. This is only a principle. And alpha I will tell angle with vertical. What all I tell you should write now. It is a common sense. Somebody on the road will tell. See, somebody on the road will tell. Suppose, imagine you place a ladder like this. This way, see, this is a wall, this is a ladder. You place like this, see, I show the ladder for you. Okay, some ladder. Not ladder, big one is not there. I don't have any bigger one here, I will get it. Don't worry. Okay, this is a ladder. If I place like this, that is, see this way, lesser angle, lesser alpha and higher theta, that is, this is vertical position. See, this will, ladder will be inclined. If the ladder is placed with the smaller angle with what all I dictate you right here, this is the case when a ladder is placed at a smaller angle with vertical and higher angle with horizontal. See, smaller angle with vertical, higher angle with horizontal. This is the case of stable ladder. Good or bad, they will tell good. See, they will tell good. This is more stable and slipping chance is lesser. Slipping chance is lesser. Whereas if the ladder is placed, see, something like this, see, gone. This is first of all, somebody on the road will tell, see, I will tell him, I will place the ladder like this. Sir, good. And climb, see, there is a wall here. I will place closer to the wall this way. I will ask him, climb. He will happily climb. You put this way ladder and tell him, see, first of all, it may not stand also. Somehow you make it stand. You tell somebody, ascend the ladder. He will tell, no, I am not going. This ladder, dangerous ladder. So, right here, what I am telling, if the ladder is having lesser angle with vertical and higher angle with horizontal, slipping, it is more stable, slipping chance is lesser. Later one question we will find, for what value of theta ladder is on the verge of slipping. Okay, then. Whereas if the ladder is having what? Lesser angle with horizontal and higher angle with vertical, it is a danger. This will become more and more unstable. It will go towards unstable. Slipping chance is more. Right? Or common sense. If the ladder is placed, see, this way, closer to the wall, less horizontal distance and more vertical distance, it is stable, whereas as the ladder becomes this way and this way, dangerous. Actually, one particular angle onwards, you cannot place the ladder. See, you cannot place the ladder. See here, I'll show it here. See, high angle, see, it is standing. If I place this way, see now, see, gone. It will not be stable. Therefore, make this note. It is a common sense. Even somebody walking in the road will answer the question. Now, last point I will tell. Last point before I go to problems next class. Next class onwards, non-stop problems. See, now, in so many questions, we will be asked to prevent the ladder from sliding, from slipping or anything. Usually word is called slipping, dangerous one. Now make a note here. How we can do it? How practically you can do it? How practically we can do it? See, I will put double sketches now. Double sketches I will write to understand correctly. How, see, in some question, this later once again I will not explain. So many times they may ask you what? Prevent the slipping. See, I will do one thing now. See, this is one case here. See, this is ladder. Vertical. Okay. Or, see, all I will dictate here. This way, or, see, or, again, or, this is the case of this way, or, I think usually I put, usually popular is what? Usually when you solve a question, see, most popular is we solve this way. I will take same way. Okay, no problem. Most popular is this way. Here, 4 cases, 1 minute. Different ways of preventing the slipping. In the question they will ask you, these are actually you don't have to bother because in the question paper they will give you do this one, but if you understand, see, second case is this way. See. Both are important. I will put here this one or this one or this one or this one. See, ladder is like this. Ladder is like this. Okay. Here, this one, I'll tell you what. Some are wondering why you are putting all these sketches. To make the subject fully clear, or this everything what I tell you right now, the closing part of today's class, or I'll tell you why I am telling it. Okay, or see, what all I dictate, I will tell 1, 2, 3, 4. 1, 2, 3, 4. Right here. 1, I am dictating 1. In the question they will ask how much you have to press the ladder at the bottom, or you write here, the ladder can be prevented from slipping by pressing here, see, by applying a force here, P, this way, here, this way, P, let it be P. In the question paper they will ask, find by what vertical force the base of the ladder should be pitched, or find what weight should be placed here. Weight is pressing only. Okay. P or W. They may ask you P or W. Why? Because if you apply a force here, normal reaction will increase, which will give more friction. So, see, suppose there is a ladder. When somebody is ascending the ladder, he is getting tension. He will look at the bottom. Hey, I am getting afraid now. Hey, please help me. What shall I do? You go to the bottom of the ladder and please press it down. See, if you go to the base of the ladder and press it down. Yes, if you press it down, he will tell, fully press it. Yes, okay, now, thank you. Now I can go. See, be careful. fully till I go to the up and leave the ladder, keep on pressing. Okay, one option. Right here. One first option is by applying a vertical force at the foot of the ladder vertically downwards, or pressing it downwards, or by placing extra weight there. Okay. Second one is by applying a horizontal force at the foot of the ladder. Where? How? Tell me. How means? Practically in the offline class, I will tell this way, P, horizontal force, P. People will start shouting, Sir, what? Sir, what is this, sir? Why? See, when you place a ladder this way, if the person who is ascending is telling, I am getting tension, ladder may slip there, I will fall down, please push it horizontally. Suppose you are about to do this way. No, don't do it. Go get out, he will tell. See, actually, if you apply a force this way, what will happen? It will help the slipping. It will slip immediately. So, when the ladder slips this way, you apply a force like this here, P, right here. But if it is, see, don't by heart left and right side. Inward push should be there. Or here, see, second case is inward push. Okay, one weight I have to show always, because somebody will tell, weight has no weight is always there. Other things may be there, at least weight is always there. Okay. See, here, inward push P, right here, both the cases. Case 1 is by pressing it down at the base. Case 2 is by applying an inward push. See here, to prevent slipping, push this way. Here, push this way. Next one more is there, P over. One more case is there. They will tell a cable, you write here 3. What is 3? I will tell you. A cable or wire or string or rope is to be tied to at the bottom. Where? Outside or inside. If you tie that cable outside here, what is the use? In that case, see, you have to tie a cable here, see, this way. A cable, inside you have to place cable here. Here, cable should be like this, see, attach a cable. Then, the cable will be in tension T. Here, cable will be in tension, sorry, not there. Sketch number 3, okay. Here, sketch number 3, a cable to be tied here, so that cable will be in tension. See, this tension T is same as your P, inward. See, at the base, you put a cable on the inner side, and when the ladder slips, the cable will prevent it from slipping. Don't put outside. If you put the cable outside, nonsense. When the ladder slips, cable will fold. Okay. Now, fourth one. Actually, question paper usually most popular is first one. See, what vertical force is required? They may not ask that one. Sometimes they ask, to prevent the ladder from slipping, what vertical force or push should be applied at the base? It should be vertically downward. Or what weight is to be placed? Second one, what horizontal force to be applied at the bottom? What horizontal force to be applied at the bottom means it should be what? It should be acting inward. It should be inward to prevent. Last one, a cable or rope is what? Connected to the base of the ladder. Which side? It should be inside. Or they may tell one more thing, a solid rod is connected to the base from outside. Okay, that also will do. See, suppose you got a solid rod here, okay, then okay. See, you can have a solid rod arrangement, some arrangement here, see, this way. Then that rod will be in compression. Both are okay. That also okay. See, all are same. See, left side P, left side T, left side C. Right side T, right side P, right side C. Over. Apart from this one, nobody will ask you how to prevent slipping at the top. See, not possible. When somebody is ascending a ladder, top you cannot go, but question they can ask. At the top, you can prevent slipping by two ways. One of them is pressing the ladder inwards, or when slipping takes place, lifting it upward. See, lifting it upward. Make a note. Question will not be there because you cannot go to a ladder and lift it there. Danger. Okay. This all you make a note. And now lastly, one thing forgotten here. One last concept is there. I will, what is that one? P over slipping I told. Okay, yes. Now, you make a note here. Make a note, important note. Important note, I will dictate. I will sit and dictate. You cannot see me. You can hear my voice. Sometimes in a question, they will tell a person or man, usually woman they won't give. Why risk them? Okay. They will tell a man weighing so and so is ascending the ladder. You want to see that he can safely ascend the ladder. Then where you have to place him? Wait here. Where he should go? See, make a note here. As any person keeps on ascending the ladder, his tension will become, see, suppose the ladder is not stable. In the beginning, he is not bothered. As he goes more and more up, he will have worries. He will look there. Any problem there? See there, any slipping chance is there? See, his tension will increase. Therefore, the critical position is always where some student will tell center. No, not center. The worst case, the most dramatic or what dreaded case is when the person reaches the top of the ladder. See, at that time, he has to leave the ladder. When he reaches top, see, when you leave, he will be full tension. Once he leaves, saved that way. So, if a man or a person is going along the ladder, and if you want him to safely go through the ladder without ladder slipping, you should place that person at the topmost point. Topmost point. Sometimes called topmost rung. Topmost rung. Some people call this as a rung. Okay. At the top you place it because why? The worst case or the most dangerous time in his journey is, see, as you ascend the ladder more and more, his BP will increase. Suppose imagine some problem is there. Ladder is not very smooth there. Somebody is holding the ladder, but he is a weak person. This person is a heavy person. He already got doubt. So as he goes up and up, his BP will slowly increase. And BP will become maximum blood pressure, means tension. When he reaches the topmost position, he has to leave. A jerk will come then. Then he will tell, safe, I am at least at the top. Now better slowly jump there. Okay, now let whatever happen. Therefore, the worst position or the critical position, if it is not given in the question, if they simply tell man has to go through the ladder safely, you should place him at the top of the ladder. But make a note, sometime in the question they will tell man is standing here. Okay, let him stand there. Then you solve the question. You don't ask the man or person. You are standing here. Are you not going upwards? Examiner will tell, that is not your problem. I told a man weighing so and so, he is standing here. So what? You solve the question. Sir, he can go further. If he goes further, I am not asking you. I am asking you what happens if he stands here. Then you solve the question. But if the question is, the person has to safely go through the ladder, then the most critical or dangerous situation is when he reaches the top of the ladder. So remember this point. That's all. Now, I think nothing missing here. I have given plenty of principles for you. Yes, last part is there. Yes, last part. Okay. Okay. This also I'll tell today only. Why? Because next time onwards, see now, in the class you tell, see how harshly I will talk. I will tell, not clear, leave the class. this much effort I have put in the previous class, you can't understand correctly, you can't go, if you go through the class, ordinary person can understand. See, now, when you solve a question on ladder friction, see, when we solve, very, very important, I won't repeat once again, very, when red color rounding, okay, very, very important. When we solve any question on ladder friction, it looks like what? Looks like a beam problem. See, not like, see, so far all point contacts, concurrent force systems, right here. So far, only concurrent forces, So, sigma fx0, sigma fy0, and sigma m0 is not applied so far, not applied. But for ladder friction, basic conditions of static equilibrium applicable are sigma fx0, sigma fy0, and also sigma m equal to 0, right here. So therefore, there are three equations. Therefore, three unknowns possible. Three unknowns can be calculated. Make a note. Or algebraic sum of forces in the x direction equal to 0, algebraic sum of forces in the y direction equal to 0, and right here, algebraic sum of moment of the entire force system about any point, sigma m about any point. Which point, I will tell in the question later. Any point equal to 0. Or, see, ladder friction looks like a beam problem. See, if you remember, for beams, sigma fx0, sigma fy0, sigma m0. So, now, apart from, see, that is, apart from sigma fx and sigma fy equal to 0, we have additional condition equation, that is sigma m equal to 0. Make a note, study it clearly. I will paint red color now. Okay. I will not tell. Suddenly someone can ask next class, doubt. Sir, suddenly you applied sigma m0. Why? Comment section I will write. Don't continue my class. Suppose somebody will comment that way. Comment. Sir, sigma m0, why you are applied, sir? I will tell, don't continue my class. Harsh language. They deserve that treatment. One who does not go through everything I tell, or if he does not have confidence in me, why you are studying from me first of all? Go to, there are so many classes uploaded in the YouTube. Go and study there. Okay, let me see. Go and study. But people who think I don't want to tell much actually, sorry. But what people tell, I can tell, I don't want to tell. Okay. But those people who believe that, yes, this person has got tremendous knowledge, he knows how to deliver, and we can learn from him, go through everything. Learn from me, and tomorrow, one fine day, become very strong in structural engineering. If possible, equal to me, or slightly below me. Above me, don't try, not possible. Why, I will not tell. Okay. Because as far as the basic conditions are concerned, I reach the limiting case. I don't have to learn anything now. Any question I can solve. There is no question for which, if solution exists, I cannot solve. It is not there. And one more thing, any question asked to me, I will solve immediately. No referring. Don't tell, okay, let me tell you tomorrow. No tomorrow, immediate. Question you ask, I will tell. But nobody will ask me any question. They will tell, sir, this doubt is there. Doubt also will not come. Sir, on the examination, some odd question given. I will see the question. Okay, do this way. Okay, got it, sir. That way. Now, everything I told, go through it. Next class, we'll start marathon questions on ladder friction. Question 90 is the next class. I remember. So I surely sure it will cross 100. Maybe 3 or 4 classes or 5 or 6 classes. I will do every possible problem in the lateral friction. Nothing to be left out. Maybe 5 or 6 classes, I am going to finish the friction chapter. Then I am going for that part for which I am waiting. Strength of materials, the backbone or the basic of structural engineering. Okay, thank you. We'll meet in the next class with full problems. Thank you.